Yeah, Suresh. All right, welcome folks. Welcome to the DMM working group. So this is Shri Gundavelli. So my co-chair, Depeng is on holiday. So today it will be just me, and Suresh is also here. So all right. So we have a full agenda today. Just before that, some official business. Please read the note well. So this meeting is governed under some certain IETF rules and regulations, and these are documented in various RFCs. Please read those specifications documents with respect to IPR policies, with respect to code and conduct and other aspects. And with that, so I think blue sheets, I think, please sign the blue sheets. And we need 1 minute taker, please. And I think Lyle, you agreed to take some minutes, right? All right. So we need one more note taker. Anybody else, please volunteer? Minute taker. Huh? Yeah? Carlos, minutes? No, I'll give you a piece of paper and a pen. So, okay. If you can capture some. Yeah? All right, I think we need a JavaScript as well. Anybody? All right, we can get started. So this is the agenda. So we have a full agenda today. I'll appreciate your support with respect to, moving things quickly, right? So we have totally, I think, 12 presentations. So this is the agenda, and a quick review of the working group document status. I think we have a couple of working group documents. One is on-demand mobility. I think there was a recent update posted only this morning, I believe. But as far as we know, all the authors have resolved all the issues, and currently the document is in working group last call. I think this is the third working group last call. Previously, because a few issues were identified, and we had to send it back to the authors, and the authors have worked hard and to resolve all the issues. So it's under last call. Please provide your feedback. There's an opportunity to fix any, make any final, changes. And I think there's also chair review pending. That is the first document. The second document is the Dmm Deployment Models. I think it's in a good shape, but I think there's a dependency. I think the reason why we are not moving this forward is, there's a dependency on the FPC document. We don't want to move this faster and quickly, and later, if there's some changes in either FPC document or other documents, we don't want to go back and fix this. So that's why we are just moving this on a little slower track. But overall, this is in a good shape. And next is CPDP. I think, this is one document which is tremendous amount of efforts are going into this. I think we are, way past our, original timeline for this, but, given the amount of efforts and, I think it's a lot of work is going in. I think that is one thing, but still, I think, we are almost there. And I believe, Lyle and Charlie and Marco, Satoru-san, they made tremendous, Danny, they made put in a lot of efforts, and it's coming out good. And I believe, Sprint also has an implementation, right? I believe Lyle will talk about this, but overall, this is in a great shape. But I think still one problem is there hasn't been much feedback from the working group. I think, after Charlie joined in, he made, some very good comments, and a lot of things is, a lot of changes are going in, but still we need broader, participation. Otherwise we won't be moving this to the IESD at any point soon. So appreciate some support on this. And then the DM distributed mobility anchoring. I think, Anthony, this is one thing, it was, I believe it already passed the last call at some point, but, I held it back because it was 85 pages And when I pushed the authors, they revised it. It came to 45 pages. Still, I pushed it back, and I think, editorially it was unreadable. So I said, there's no way in the world we are going to forward this. And then at that point, authors have engaged, Carlos, and the document is now around 18 pages, and it sounds, it's in a great shape. But this is almost like a reset. Even the document is like got a good work went in, but given that we pretty much rewrote the document, we need to we want to make sure this was reviewed by the entire group. So overall, but progress on this, I think good thing is there's progress. Document from 85 pages to 18 pages is and with the readability, I think they made tremendous amount of efforts. Thank you, Anthony. Thank you, Carlos. And the other one is a services for mobile user plane. I think there was one revision from Satoru-san and the other authors. There's a presentation slot. There are a few discussions, but I think I'll let Satoru-san to provide feedback on what the changes are. But this is relatively in early stages, so we need a lot more discussions. But and I think before we move to the last call or anything. Now, so with respect to maintenance documents, I think there was one IESG discussed on 4283, but looks like it now resolved. I think Charlie, congratulations. Suresh.
Yeah, Suresh Krishnan. So yeah, it got resolved. So Charlie and I had a call last week, and we found a way forward, like that will resolve the discuss. So it's like, it was there for, I think, like 390 days in a discuss, and I think it's done now. So it's I just sent the approval notice yesterday.
Right.
It's gone, so it should be in the queue, and it's all good to go. So basically, the sticking point was the RFID stuff, and there was we couldn't find stuff on the mailing list for supporting allocation for those things, and now it's kind of moved into an appendix saying like we consider this but didn't add, and so like that cleared the discussion. We are done with that.
Excellent. Thank you, Suresh. I think, thank you, Charlie, for resolving this. I think, this is now in the publication queue. Excellent. And the other one, MAG multi-homing, this is published as RFC 8278. This is very good. And now there were two, moving on to the license statements, there were two LS statements that we received from 3GPP, from CT4, I believe. One was on the RA, semantics with respect to coloring. I think, I worked, I think I posted my response somewhere in February, and the working group had the opportunity to review that response, and based on that feedback, we officially provide that response back to 3GPP. There was second, LS statement from 3GPP on the user plane study. I think we haven't provided a response, but I think we need to, I want working group to provide any feedback. I believe it's more an opportunity for us to they provided the status of what's happening in 3GPP with respect to user plane study, and I think we probably can respond to that or whatever. Right? I think we need to review that and provide our feedback. Okay.
Suresh Krishnan, so I haven't received this liaison statement. So the first one I have, and the second one I haven't. So like there is a liaison statement, the newer liaison statement for the first case for the service continuity usage. So we discussed it on the 3GPP IETF call last week. And the second one, I have no idea. So it's not like, so we need to figure it out.
Yeah, Satoru-san, yeah.
Satoru Matsushima, my 3GPP hat on with fancy IETF t-shirts. Yeah, this is the already approved study item in 3GPP CT4. I'm just waiting the CT chair action.
Okay.
It will be in official way.
That's fine because it said liaison. It's fine if it's like something that's done.
So maybe it's not. Okay, it has to come into the IETF system. That's why not, it's not created yet. But with respect to 3GPP, it's already created. Maybe, I should have held it, but yeah. But we know it's coming. Yeah.
Okay, perfect. Thank you.
All right. So moving on, I think that is the update with respect to working with documents. And now we'll move on. I think I need some help with the timers, please, for each this thing. If somebody can maintain some timer or something, I'll greatly appreciate. And now the first presentation is FPC update from Lyle. Lyle, you have 20 minutes. And I think please somebody if you can track time, I'll greatly appreciate. But otherwise.
Well, this will go short. If I stop breathing, it'll just end abruptly. So.
Yeah. All right. So please, you're in the, yeah,
Yep.
Perfect. You know,
All
this,
right, next slide. Okay. So just a reminder of what we're talking about with FPC. So we're here to enable control plane, data plane separation. Our model is pretty straightforward. We have a mobility C-plane client. So we have a mobility C-plane client that's embedded with FPC. We're then moving with the agent, and basically it's controlled, or the agent's essentially provisioning the data plane node or DPN. So this allows us to support, and we've got in the model several things like multi-tenancy, we've got policy provisioning, we've got quite a few features in here. It's a rather large document, about 50% of it sitting in there as Yang. Hey, Shereen. So this is just the change list since version 9. I'm not going to go through everything. There's just quite a bit. I'll only go through the big highlights. Next slide. So the biggest change in the system is templates. So before we had a very structured model, and what we've moved to is a templating system with a templating language. So what we're trying to do is essentially simplify the development of any further extensions of FPC. In previous versions, we've kind of gone down the rabbit hole in extensions for 3GPP or other different structures. And so we decided to take a little bit of a step back. And with Charlie's help, and we did daily calls about an hour each day for weeks is an understatement. We kind of arrived at this template notation. So every template that you see in there is going to have a set of attributes. And we have a couple of indicators that are important to us. So the Extensibility Boolean basically lets us know whether or not this template can be further extended as we go through the policy process. And that's really important from a policy design point of view, right? We're really talking about the ability to set up when we leave the extensibility open or true, the ability for people to go ahead and really define new templates or restrict templates. But by setting it false, right, we're really kind of locking down even at the beginning or some later point as we go through the template design, what people can do from an operational perspective. The entity state, and there's several states to this, we'll talk about that here in a little bit, allows us to kind of progress. What we're trying to get to when we're basically adding to a template as we go through the various lifecycle stages in policy is we're trying to get to the point that a template is configured. And what we mean by that is there's sufficient information in the template so that we can actually take action on a DPN. And what we then want to see on the DPN is it move from the configured state to an active state. So then we know it's actually in play, it's running, and we know it's being applied to the mobility context in question. We also have versioning just so that we can track, it's just standard maintenance stuff. Now, as a part of this and the specification of attributes, we had to actually bring up a definition notation. And so you see all the various items here. The one thing I would point out, though, is the last 3 items really are about non-mandatory attributes. And I think what's important here is that extensibility attribute when it comes into play, right, especially when it's set to false with non-mandatory attributes, right, you can see a lot of different use cases for that in terms of how we can handle it. So next slide. So policy templates. So we did have policies before, but now really policies are just effectively templates, follow a very specific pattern for us. So when we talk about a policy, we reference it by its key. So if you see something like policy key or DPN policy key or DPN key, any sort of the dash key notation, it really is a reference. And when we're making reference or a particular entity sort of configuration on the template, we really have to have the initial reference that we're talking about. And then those attribute expressions that we just described. So a good example of this is in the DPN. We actually have the ability to push in DPN policies. In the previous version, these were referred to as installed policies. You've heard them also referred to as configured policies. And so what you'll see here in the DPN is essentially those policies are now underneath the DPN. They're installed there. And you'll see then the reference to the policy key in question and then any sort of attribute specification. There's several entity config blocks. This is a overall design pattern, and you see the various locations there. So this is kind of a rinse-repeat architecture and allows us to really kind of simplify the overall design of the document. Next slide. This is the policy model. I'll point out to you that everything's still there. You still have your actions, you still have your descriptors. Rules were actually a substructure under policy. They're now pulled up and they have the same depth because of the template architecture. So this allows us to kind of mix and match rules inside the policy space. And policies still have the same idea of essentially a search space with precedence for rules. The biggest piece then is that as we kind of progress with this, the designers can start out with the templates at the action or policy level and keep refining them, or not, right? They can just basically include them as they go to rules and policies. Next slide. The overall life cycle is pretty straightforward. So your first step is really up at the top. You design what you need underneath the policy information model. It can be as simple or as prescriptive as you like. A good example of very prescriptive is things like a policy that literally just says block everything incoming port 22. Something very generic would be a drop action based off of an RFC 5777 classifier. So here's where the entity status comes into play. If there's not a lot of configuration, we refer to the status as initial. Partially configured means more attributes have been added. Configured means we actually have gone to the point we can actually activate this somewhere in a context. But typically we won't expect anything beyond probably partially configured at this point in the model. The next step then is really in the middle, and that's to really apply it to a DPN. So this is where we see something that's really defined at the tenant level now being installed into a data plane node. That doesn't actually mean it's being used yet, right? So we're just trying to make sure it's sitting there, it's ready, and it's available. And that's at DPN policy configuration, which we referred to as installed policy or configured policy and past provisions. And then finally, you actually see the application of this or the assignment inside the mobility context. And there, we'd like to see the actual configuration progress closer to configured in terms of the model. And hopefully, right, if it's actually being applied, right, we'll see that entity status change to active. So when you look in, you should be able then to see which policies were not only installed, they were potentially maybe pre-provisioned or pre-configured on the mobility context in question, and which ones are actually active. So if you're familiar with things like LTE and VoLTE, this is a lot of what we do, right, is we set a lot of stuff to like the configured state, it's rapid ready to go, and then we'll go active once we actually decide what, which one of the options we're applying for the negotiated call. Next slide. Topology and service, a lot of renaming. So this is the old model. We do have a proposal out this week to get rid of service endpoints, but I'll kind of go through this just briefly. We essentially have DPN groups and peer groups renamed, and using the service group nomenclature. Service endpoint is currently a kind of an older mechanism from the previous design. It's currently under review with the co-authors to be eliminated. And then we still have domain. And we've also had the DPN structure, which we previously talked about. So, and just a reminder, right, installed policy is gone. So it's now sitting under DPN. So next slide. So this was the relationships, and this is also why we were a little, this is really the last thing we went through for improvement. You can see kind of that service endpoint and the DPN being really scattered all over the place. The current proposal is to take the attributes that you see under basically, I believe it's protocols as well as features now moving over to this interface in the service group. And we're essentially going to eliminate that in the next update. Next slide. Mobility context, although it goes into the new template model, a lot of the stuff that we know is still there. So we do have the extensibility attribute here. It is a template. So the interesting thing is you can lock context now and make it immutable. So that has some very interesting applications in the network as well. We still got the basic parent-child types of designs, the mobile node domain, and the DPN assignments for version 9. Now following this, one nomenclature name is the service data flow. We now allow that essentially embedded rule, and all of that specific terminology is gone. We do have one reserved key in the structure so far, and that's for unassigned DPNs. There are some architectures that do try to track rules or policies that have not been assigned yet to a specific DPN. So we just set aside that name rather than having the embedded rule as a separate structure. Next slide. RPCs did go under an overhaul. So we migrated to a Yang patch style, but we're not quite compliant, right? RPC is really, we have to remember two things. One, FPC is an information model. So we're not here to talk a lot about Yang or other structures. The other thing was, if you recall, right, we have the ability upon the first application of an RPC in the old style conf or conf bundles to immediately reply back with what the client needs to continue call processing, and then do a result later in a subsequent response, so that we can basically sync up the control plane with anything the data plane's doing. Yang patch didn't really facilitate that sort of concept. So what we did was we basically went ahead and migrated to that style. So your configure message does look very much like a Yang patch. You now can do multiple edits, so there was no need for the conf bundle. And we went ahead and migrated all errors to a common error format, once again, kind of following Yang patch and some of the guidance there. Next slide. The output is where we had to diverge a little bit. So what we have in the response, your typical Yang patch will just basically respond back with an OK or an error. What we had to do was basically have the concept of subsequent editing, which is the idea that if you send an edit down to the agent may have to make subsequent edits on its own in order to make something work. The easiest example of this is if the agent is allocating the tunnel endpoint IDs, then clearly the agent's going to need to make an edit. We used to send that back as one large document. I can tell you that in production, that's really hard to parse from an implementation point of view, and has been a pain point for us for performance. And so what we did was basically go ahead and make these little micro adjustments with subsequent edits. So now you can actually, almost like a log, figure out what the agent's doing on a step-by-step basis, and it makes it much easier, if the client cares, to kind of sort out which edits are important to it or not. So that speeds up kind of that return processing much faster in the response. The other thing to note is, unlike the previous stuff, we do have more more verbs under update. Our old model, until we went to Yang patch, was just basically create, update, delete. Under Yang patch type designs, we now have things like merge. We have our traditional update. We have move, which I think as we add more examples, I'm looking forward to things like just moving the DPN entire structure. So we could do things like anchor mobility as a very concise command in some of the subsequent stuff. And that kind of leads into the next slide. So this week we have a proposal on the books with the co-authors to eliminate service endpoints. We'll have that out to the group once I kind of get feedback from my co-authors. We definitely have to add an example on topology selection. We'll be adding more examples as well in terms of the other features, so we can highlight key features. And we've got lots of little edits. But quite frankly, guys, at this point, we just need feedback at the end of the day here. So we're running out of excuses and everything else to kind of go much further with this. So I'll leave it at that. Open it up for questions.
So can you provide an update on the implementation, Lyle?
Yeah, we're in, oh my goodness, almost 2 years now of having running code. We've been demoing, if you see the MCord project, depending on when it's launched. So the overarching project's called C3PO. The controller underneath may be Onos. If it is, it was developed either by Verizon. That's one implementation. There's another Onos FPC implementation also out there that has been developed by actual ONF. And then you've got the ODL implementation developed by Sprint and now GS Labs.
Okay.
So those have been floating around for well over a year now. Now we're sitting on version 4 on that. And a lot of our complaints, basically, and what you see like with the configure and stuff in version 10, and that migration to Yang patch is directly from the feedback of all 3 implementations.
Mm-hmm. So you plan to migrate to the latest version?
Yes, I think at this point, I don't see a lot of changes coming. So I've went ahead at least, so I'm the project lead on the ODL side. So on the ODL side, I've given the devs on the next couple of sprints a request to go ahead and start analyzing and then scheduling.
Okay. So one more question. What else is left with respect to completion? Okay, reviews. That problem is there.
Just we have the text ready to make the service endpoint elimination change.
Yep.
And then it's examples. So I want to get in, obviously, one more example for topology, and then adding more examples just in the examples section. And then the rest of it is just editing. And the more feedback we get, obviously, the more edits and changes we would make.
Okay. So I think the reviews is the problem. I think, we need to get that fixed here.
Suresh Krishnan. So not really about the content, but the form of the document. Okay.
Yeah.
So one of the things that has happened in the IETF very recently, probably like a month ago, is the NMDA stuff. Okay. So are you going to go over the document and make sure it's compliant with whatever is in 8342?
Yeah, that's the plan, and I haven't. I'm actually going to get someone to sign from Benoit. Right, it's going to sign it.
They're not going to tell you how to fix it. They're going to say what's wrong.
Yeah.
And so basically the idea is like how, so in very short thing, right? Like, how is configuration and operational state maintained in the document? So I took a quick look at the latest version, and like there is like stuff to fix.
Yeah.
And I don't think like whoever Benoit assigns will fix it. Like it needs to be from us. The question is,
it'll be, but we'll obviously be working with someone to kind of work through any sort of questions we have, right?
Right. I'm just trying to avoid this additional round trip, right? So if you can actually look at 8342, now it's published, it's done. Yeah. So there's no more like fiddling around with it. So take a look at it, see if you can take like an initial cut at like, what you need to change. So basically the idea is like you don't keep duplicate stuff in configuration and operational state trees. That's like, the very first thing you need to look for. And if you get that done, I think it cuts down the amount of things they're going to find. And I would really like that, like in addition to whatever Sri is going to do, like the reviews and everything. But you can probably take like a parallel pass at this.
Okay. Yeah, will do.
Excellent. Any questions, please? Questions, comments, feedback? Yeah, this is a problem. All right. Okay. Next, Carlos on distributed mobility anchoring. Lyle, you're going to start. Yeah. This is an update on DMM. Carlos, go ahead.
Yeah.
Distributed anchoring. Sorry. Yeah.
So, Anthony couldn't make it for today's meeting, so I'm presenting on the behalf of the authors. Please, next slide. So, this presentation will be brief because, as Sri mentioned, we did a lot of changes, and it's like very different. Well, very different. It's a different document in the sense that drastic changes were made. So, we basically this meeting, what I want to request is feedback from those that have already read the document and ask for additional reviews. So, I will just briefly review the status, overview of the document, and then the next steps. So status, as Ri mentioned, version 7 had like 46 pages, and we drastically shortened the document because we believe that was one of the main messages from the working group. The document is too long, it's too complex, we need to make it shorter and make it more understandable. So now version 8 has 15. Of course, due to or as part of the process or because of the process, there are still some inconsistencies that we need to fix. So it's not meant by any means this version 8 to be ready yet, but we wanted to have a version available for the working group to basically let us know if this is on the right track or not. The main goal when we did this shortening was to reduce complexity. So we have simplified the terminology, which was one of the, I think, main potential problems of the document. That terminology was a bit complex. And also the drawings have been simplified and many of them has been removed. We have mostly focused on the data plane, although control plane, of course, is there because it's an important piece. We have completely removed parts about hierarchical networks and network mobility. We believe that those things could be address in additional documents, separate documents, if the working group believes this deserves so, but that was not the main goal of the original document. The scope of the document is basically limited to 3 things. One is the case of nomadic users. So, okay, there is no really an anchor there, it's change of addresses. Then there is the case of keeping the anchor and moving the traffic to the actual location of the device. And the third case, which is basically the anchor relocation, so actually moving the anchor. So those 3 cases are the ones that we want to document and in the document. And we also focus or highlighted that the document is informational, so we also try to modify the language and the focus to keep it as information. So there is no solution, normative text on this document. So this is the overview of the current structure of the document. So it's been simplified, and I think we will be merging section 4 and section 5 as based on some feedback that we already got from Marco, because there are some duplication there. So even though there are some additional information that we aim to add, also based on that feedback, since we will be merging, we don't expect the document to get longer than is it as of today. So next steps, and this is the main message I want to convey or I want to ask you, is we have done a lot of changes on version 8. So we first need to get some feedback like, okay, is this on the right track? Knowing that it's not meant to be finished, it's not meant to be the final document at this point. And if so, we would like to have additional reviews. Marco already provided some offline comments that we will address, but of course we would like to get more comments from the working group. If we go those reviews, the commitment from the authors is to really push this and to get a document ready before Montreal, because this has been sitting there for a long time already. So this is, you have any early feedback on the current status, and if in any way, if we can get some volunteers, that would be very appreciated.
Okay. So from your point of view, Carlos, this is almost ready. I know this is a reset from working group process point of view. This is a reset. We need to go through, it needs to go through a few more reviews and all of that. But from your point of view, you think this is?
From my point of view, we need at least one revision just to ensure that everything is consistent, to also address the comments that Marco made. I don't know if Marco is here or not. I think. Yeah, I don't know if you want to comment, but there are some things that he commented and that needs to be fixed. And they are not complex fixes anyway, so we can address those in one revision. But then, of course, since it's a very different document, one review is not enough. We will need more.
Right, absolutely. Marco.
So to answer a couple of questions. So this question, is it on the right track? Yes, I think it is, as I provided feedback to you already. Regarding Sri's initial question, in terms of readability, there is space for improvement. I think the biggest improvement is really the cut of the document, which may motivate people to start reading, which is a big improvement.
Absolutely.
When I started to read, I preferred adding my comments directly to the document, and that's why I didn't send it to the list, but to the authors. Carlos and me had a discussion yesterday, and I think we are pretty much in line with what needs to be improved. I think the terminology chosen for this generalized function, it's very nice. It's easy to understand. I think the clarity in how to use them suffers a little bit from the cut. So maybe a little bit too much has been cut. And I think the cut in the different cases, which move from hierarchical and many different deployment options to basically 3, which is the nomadic case, into cases for session continuity, one with the other one without anchor relocation. I think it's a basic set. And the working group has to see if this is the main message they want to give or if additional cases need to be addressed. So I think I provided a couple of hints what should be added, and I think the document can be improved very quickly.
Okay. So, why don't you guys take the AI, do one or two edits, then we'll ask, engage few more authors, few reviewers, right? I think maybe Suresh, yeah, go ahead.
Yeah, Suresh Krishnan. So, Marco, one of the things I can also suggest is if you want to do this kind of exchange where you want to contribute changes, I don't mind if you do this thing on GitHub, put the document on GitHub and he does PRs for things you want to change, and then summarize to the group. Like I just want the group to see like the final changes like that are getting done and why, but use any intermediate tool you want. I've seen like a lot of groups using GitHub for doing this, and that's perfectly fine. I support doing that if that's what you want to do. Okay.
Okay. Yeah. So overall, but this is not the right track. But I think this is a reset. Let's make sure that we don't move this too quickly without making sure it goes through proper reviews, right? I think. But again, I think thank you, and working group, please review and provide feedback. So yeah. All right. I think next is user plane protocol study. Satoru-san. Okay, can I use this? Yeah. That's from 8 foot to
Hello everyone, Satoru Matsushima, my 3GPP hat on. I'm reporter of the study of the UPPS in 3GPP CT4 working group. Let me introduce the study on user plane protocol at 3GPP. So I suppose almost people already know about the study item document, which is approved on the 3GPP CT4 CT plenary in last year, is that we revisit the user plane protocol. So the background here is so far there's no intensive study on user plane protocol, while in the 5G there's a drastic change in the control plane side moving to the SBA. So during that, we can see a lot of the IPv6 adoption in the production network. So that may introduce a lot of space to improve the user plane operation in the IPv6 network. So that's what the IAB recommend the other STO to revisit their specification that can be run much more efficient in IPv6 only network. So CT4 decided to revisit the user plane protocol to investigate potential limit of the existing user plane protocol, and also seek the potential benefit of alternative user plane protocol, including IETF solution. So that's the brief background. So how we proceed the study is here. The objective is the phase approach. So phase one is just liaise with other SEO like IETF to collect the candidate user plane protocol, and also to give it some information regarding existing user plane protocol like a GTPU, which defined by TS 29.281. Latest version is version 15.1.0. And also phase two, following the phase one, is to set criteria for protocol selection based on the release 16 requirement. It's not release 15. And also evaluate the candidate protocol for that, based on that criteria. So the purpose of this objective is to study will contribute to protocol selection. So that the other work will follow that study to make the decision. So how to approach that phase two is the one with the approach is investigation. So that investigate solution alternative to GTPU, including IETF solution. So it may include other working group in 3GPP, like round 3, CT3, or SA2 if needed. And also a little bit of wait. So after that comparison will be we do. So compare GTPU in other solution to see if there's matter for user plane protocol swap. So after that, we will see the protocol recommendation will be the outcome of the phase work as the TR 29.892.
Charlie?
Yes, I'm Charlie Perkins from FutureWay. So you highlighted that term control plane impact, and obviously GTPU has a lot of very long history and is well understood. So if you want to not have any control plane impact, that means you're going to be running GTPC. And I'm not quite sure how, it would be difficult to imagine, you might say, a lot of alternatives for something that can be controlled by GTPC.
Yeah, that's right. That's a good point. So as you mentioned that, so GTPU is tightly coupled to GTP control plane. So when we see the opportunity to swap the user plane protocol, we may also see the impact to the control plane protocol, like a GTPC. But nowadays, we also already have the cups to make sure the user plane, control plane decoupling. So that's also be impacted by a user plane protocol swapping. So we also ask to the investigate the study how much the impact to the those existing control plane protocol.
So does that mean in order for us to be effective, we should read cups?
The cup, yes, cup architecture will be much makes sense.
Okay.
Yep. GTPC is very difficult.
Okay. Kalyani?
The release 16 has a study item in SA2, which is looking at UPF to be connected to the services-based architecture, which means the UPF could have the services-based interface in the architecture. So you may not necessarily be restricted by GTPC. It's actually N4 in release 15 next generation core network. So it's N4, which is PFCP based, which is specified by 3GPP. And in release 16, there is an opportunity to look at an API from the user plane to the services-based architecture.
Maybe yes, but there are a lot of things happen on the SA2 side, but this is the CT4 work. So we are awaiting from SA side what could be required for the
but if we are looking at release 16 SA2, we'll also be doing a study in parallel in the same time frame. Actually, their study starts even before CT4. So IETF, from IETF side, we should be looking at something that can go into both CT4 as well as SA2.
Suresh Krishnan. So Kalyani, so is there like a LS coming from SA2 as well?
That just got approved 2 weeks ago. So the study item, we can either we can copy them, or because we have participants in both sides, we can tell our delegates to get an LS sent, or because we are bridging the two sides, we can send, when we're responding back to the CT4 LS, we can inform SA2 also, because the CT4 study says if there are impacts to the rest of them, like control plane impacts, or they could go into the RAN3 and the SA2 as well. They actually mention them as well. So they know that there could be impacts to that we can copy them.
Okay, Suresh Krishnan. So I have a suggestion here, okay, because I think this is going to get out of hand if we follow something ad hoc. So back in the LTE times, right, we had a spreadsheet which maintained a dependency list between 3GPP and IETF. So it had something what group, RAN 3, CT3, CT4, the name of the TS or TR, whatever it is, and then the IETF draft that corresponds to it. And I think we need to start tracking this more closely because otherwise it's going to get out of hand. Especially if like SA2 and CT4 don't agree what this is, then we need to have some kind of tracking. So I'll take an item, Satoru-san, me, and Samita, and maybe Sri, you. We sit down, write something up, and send it to Georg Meyer and Gonzalo.
All right.
So they can track this. We had a call last week for the coordination, 3GPP IETF. We have a coordination meeting, and we had no idea about any of this. So we need to make sure that we kind of keep track of all these things, because it's not just this working group. I'm sure it's going to spill over into the other thing that came up as an LS was like 6-man related, for example, right? So I really think we should put better effort into coordinating this things.
Yeah.
Sure.
But
Yeah,
also
that's-
the
that sounds
SS1
like-
CT4, the kind of the 3GPP matter. So I don't want to improve the much about that.
That's fine, but we need to know that like potentially different things are being considered by different parts of 3GPP. That's something I think it's already interesting to us.
Yep.
Okay, thank you, Suresh. Yeah, that sounds like a good idea. Yeah, please.
Question for clarification. If, for example, if we in the VT16 transaction on Huawei, if a new protocol decided by selected by IETF and adopted by the CT4, my question is whether this only used for 5D or both 5D and 4D. This user plan protocol.
This is for 5G, yeah, mainly for 5G. Yeah.
For the VT16, there's also both 5G protocol and 4G protocol. My question is whether this new protocol selected by the IETF is only applied for VT16 5G, whether it's also applied for the VT16 4G.
So let me clarify something. IETF is not selecting any protocols, okay? There's no one silver bullet. There's nothing like a deep protocol. All we are going to do is we'll standardize protocols, based on consensus, based on what the charter approves. We'll characterize the solution, but we are not going to pick any solution. Exactly like what we did with IPv6 transitioning or other approaches, that will be the plan.
Maybe I need to prove my wording. IETF for our standard group, we need to define a protocol, but this protocol is selected by the I3PP.
Yeah.
My question is whether also for the 4G with the 16, whether select the same for the 5G.
We do not know. That's within this.
N9
Yeah.
is only for 5G. It's
S6, it's not
but
S6,
then,
right? Yeah.
the 4G can connect to the NGC, but N9 is the only one that is in this.
But I guess his question is it S6 related, right? Is it on the S6? Not okay, N9. Mainly the
N9,
S2, S2.
yeah,
Yeah,
N9.
okay, S2A, S2B.
Because he, as the
That's fine.
reporter of this, what's the goal of this, this in the CT4? This question.
I think Kalyani clarified, right? It is not on S5 or, S8. I'm forgetting the 4G interface, S5 or S8, but mainly on the, N9 interface. So, yeah. So, yeah.
This is
please,
Rashmit.
Ashwin. Yeah.
A few comments actually here. First of all, the study group here, what we are trying to do is just to analyze different protocols. The selection, as Sri actually indicated, it belongs to the 3GPP guys and the CT4. So those are the guys who actually will decide ultimately what happens.
Yeah.
Our objective is to provide a thorough analysis of different protocols and contingent protocols that provides the base for 3GPP to go and do their selection.
Right.
That's
Absolutely.
one. Regarding control plane, the idea is not to have the control plane untouched. Through the analysis, we will find out which of these protocols have what type of impact on different interfaces and different protocols across the 3GPP. Once we actually have all the data collected, then we can actually compare them and see which one actually provides minimum or maximum impact or like changes into 3GPP interfaces and
Right.
control plane.
Yeah, no, absolutely, Ashwin. I agree with that. Last comment. Yeah.
Yeah, Joe Scaragianis, Huawei. Just a question on the liaison coming from 3GPP. It's mentioned there set criteria of protocol selection based on list 16, but how then IETF is involved in this process? So I assume that this is something that the study item in 3GPP will do, but how IETF will actually contribute to the criteria, that will be used to select a solution.
Yeah.
Okay.
That's
Thank
what
you,
I'm trying
judges.
to explain in the next slide. So we will ask any information regarding the user frame as protocol. But that would be bunch of the solution of a protocol there in the IETF side. So we hope that the much easy to digest comparison or criteria is really appreciated.
Okay, but what I mean is 3GPP waiting, for some input regarding the
Right.
selection criteria from
Right.
IETF or not?
Right. Yes, of course.
All right, I need to cut off the mic, please. Yeah. Okay, quick comment, Charlie. Yeah, go ahead.
So just on the last slide, you said any info that would be useful. And one thing that's really going to be useful is a nice protocol that shows you how to set policy for separating user plane and control plane, i.e. FPC. And so maybe we should try to impress them the value and the power of our
Right.
current methods.
Yeah, regarding any information, yes.
Okay, so discussion, just closing off on this. So Charlie, if you want something to be sent to 3GPP about the existence of this, which I'm pretty sure they're aware of, but if you want to officially send a note, we can send a note. We can send an LS. So it's us, the working group, to put together something and say, okay, let's do it. And then I can ship it off to SA2 saying like, hey, we have this document like you can use for FPCP separation.
Actually, we are out. Okay.
I appreciate the line is closed, but just a clarification on a previous comment, because I think this is fairly crucial. And I believe the statement was, is the IETF to provide selection criteria, or is the IETF to provide information and the 3GPP applies their selection criteria? I would assume the latter, but I heard the former. So I just wanted to be clear on that.
No, I think it's clear in Satoru's from my, yeah.
I went to show the last slide.
Okay, okay, yeah, please, in it, yeah. Done? Okay, excellent, yeah, thank you. Next is Dino on Lisp for, okay.
15 minutes, right? Sri?
Actually, 1 minute, if you can save us 1 minute, that will help. Okay, all right. So Dino negotiated 15 minutes, otherwise he threatened that he'll not do the presentation, so you have it, yeah.
You just took 30 seconds now. So I'm going to talk about Lisp in the mobile network. We have kind of two forms of mobility in Lisp in the handset itself, which we're not talking about here. This is purely putting Lisp in the carrier network. So just some high-level goals. They're very high-level. We really want to simplify the mobile network. We have new latency requirements. Some people say 1 millisecond for VR, AR applications. We want to address newer and more demanding applications, like the size of the number of things we have to keep track of the network. If we use a pool-based mapping database control plane, we could probably scale and secure in a more centralized way. This should make management easier, so we don't have to touch so many nodes in the network. And we can reduce OpEx through incremental deployability. It's pretty much been proven over the years that using overlays that you could deploy things incrementally and not have to touch the core network, put things on the edges where you need to. So that's the sort of approach we want to take here as well. Using a dynamic encapsulating overlay, there's a lot of judgment about if GTP is static or dynamic or provision dynamic or whatever. It really doesn't matter, but it's a way of putting headers on packets dynamically when they come in and not having to set up tunnels that may or may not look like virtual point-to-point links. So we think we can do address management much simpler by having the devices that are sending, that are originating and consuming packets in a mapping system and not the routing system. And we believe we can do fast mobility handoffs. In this, we have various ways of doing handoffs. We have a couple ways of doing signal-based handoffs and signal-free based handoffs, meaning that when you move, you don't have to talk on the control plane. It's definitely a make before break. We could talk about that at some other time. It's not in this presentation. And then we really want to focus, when we look in Lisp, when we talk about mobility, we say EID mobility, which means we want to move a system from any layer 2 link to anywhere. So we want mobility across carriers as well as carriers and non-carrier networks. So we want to be able to roam between a carrier LTE 3GPP-based network to Wi-Fi. And throughout the presentation, anything you see in green are referring to EIDs. Can be opaque addresses. They're not in the routing system. They're put in the mapping database as keys to look up, and the routing locators are the attachment points of those EIDs to the underlying system, and the underlying routing system does know about them and does route them. So let me explain how it works. We assign UEs EID addresses. The UEs do not run Lisp. The GNodeBs and the UPFs are Lisp XTRs with our loc addresses. For those of you who don't know Lisp, a Lisp XTR is a box that encapsulates or decapsulates packets. So when an encapsulator encapsulates packets, what's in the outer header are the RLOCs, so the underlay can route the packet to the decapsulator. The underlay is the existing EPC in 4G or the NGC in 5G. To me, these are just new terms, but it's the same IP network that we're sending packets over. It is the underlay. The overlay runs over the NGC and the internet, and that's another holistic view where maybe an eNodeB can encapsulate a packet to a top-of-rec router in a data center. Talk about that later. Lisp mapping system can run anywhere in the NGC, and at this point in time, the recommendation is the carrier would manage this mapping system. That's modulo where the roaming scope is for the EID. Encapsulation occurs over the NGC and not the RAN. We will not have encapsulation overhead on the bandwidth and resource sensitive RAN. Encapsulation format is GTP or Lisp with real-time setup. I'll explain later why it could also be GTP. Maybe I'll get to it sooner than we think. Yes, I'll get to it sooner than we think. GTP, any Lisp, VXLAN, it's just encapsulation. Get over it. It's supposed to be a joke. Nobody got it. So, pros for encapsulation. Does not change the user's packet header. Okay, it's a standard violation to change anything in a header that you're not supposed to. The only thing you're supposed to change in an IP header is the TTL and the checksum. IPv6 doesn't have a checksum, so you get to save cycles not doing that. We want to identify a user is always maintained while staying private. Okay, by doing that, we keep this identity. That's the pros for encapsulation. Middle boxes can maintain flow state due to no header translation. Overlay and underlay address families can be different with encapsulation. Debugging and monitoring always tells you where a packet is from where, I should say from who, from where, to where. That's a very useful thing, where when you do address translation, you lose bits, you destroy bits. Okay. The cons for encapsulation is that you have packet overhead. That is the cost of encapsulation. It's very clear. We use tunnels all the time. I believe we're at the point in the internet generation where we have enough bandwidth and resources that we can deal with this overhead because the features that it gives are pretty powerful. Oops. Okay, just a quick look at the Lisp encapsulation format. The host builds this packet here. Okay, and the host dictates the length based on its application. The inner header contains EIDs. Routing system does not see the EIDs. What's added is always a fixed header. So the Lisp encapsulation, no matter what features you run, is always 16 bytes. An 8-byte Lisp header is prepended, and then the UDP header is prepended there. Destination port in this UDP header is a well-known port, and the source port changes based on a 5-tuple hash of the inner header for entropy. The outer header is the address family based on where the EID maps to. If an IPv6 EID maps to an IPv4 RLOC, then the outer header is an IPv4 header. It's as simple as that. Okay, tap it.
I'll read. Yeah, I did.
And Lisp has a capability of negotiating Lisp crypto, data plane encryption, between the encapsulator and decapsulator. That's the bytes in the packet that are encrypted. So the inner header is obfuscated, therefore you get privacy of the host's IP addresses. I'm wondering why this doesn't work. Huh? No, it can work. It's not here. You get to tap it for me.
I can see that. Okay.
So this is my obligation to the 3GPP design, that I make sure I put up a diagram that looks like a 3GPP diagram. So this is, what?
3GPP diagram looks much better.
Oh, well, I just copied it from Kaliana, so, and I highlighted color coding. So this is supposed to be this is Lisp inside a 3GPP diagram. It doesn't really mean much, but I'm going to show you some more user-friendly diagrams. But just showing you that there's a mapping system that's part of the session management system, and that's the control plane in red. And then the blue boxes are the data plane, and then the data plane runs. Tap it for me. Thanks. So I'm going to go through a couple example packet flows, which will just show how we plan on doing this. If you look at the white arrows, we're showing the communication path here. So in this example, we're showing that the left UE wants to send packets to the right UE. And of course, we want to do it on the shortest path. That's the whole purpose of this, is to have 1 millisecond low latency. And so where you see the green arrows, those are regular packets that are being sent that are unencapsulated. So the packet that flows over the RAN are packets that are being originated by the host. The G-Node B then will do a lookup for this guy's EID. What the mapping system returns is that locator, the IP address that's routable in the NGC, and basically encapsulates it. So you see the red line there, and then the decapsulation happens and sent over to RAN. Okay, next. This is showing an example where a UE wants to talk to a server. And it's a server that doesn't support Lisp. That's an important consideration. This is a server that will support Lisp, meaning that there's a Lisp XTR somewhere at the site, at the data center, or wherever it is. So we'll show you the first case. So the UE then sends a packet to the G-Node B just like it would today. No changes to the UE, no changes to the RAN, and definitely the air interface side of the G-Node B doesn't have to change at all. What the G-Node B would do a lookup for this thing, thinking it's an EID, but it's not. The mapping system will return back that this is kind of a default EID. So we get return back as the RLOC of that UPF that you see there. And then the encapsulation goes to the UPF. UPF decapsulates and sends the packet natively into the internet, which can get routed because it's a non-EID. So we know the routing system here could route the packet to the destination. Next. This is the example where the UE sends it to the server where there's an XTR, and we just see that the encapsulation doesn't have to go to any of the UPFs, it can go directly there, and the mapping system could have that RLOC stored for that EID. Next. Okay, this is going to show you the mobility case. What we're showing here is that the UE is talking to a server, and the UE is going to move over to the next G-Node B. Okay, so as we showed before, we just do the encapsulation here, and then decapsulate and send it to the server. Go ahead, tap it. So when the UE moves, what happens is this G-Node B sees that 2001::1 now has landed here. He's discovered that either by a data packet or by the session management or connection management part of the 3GPP protocol. What gets registered to the mapping database is now his RLOC for that EID instead of that one. And then these guys will get notified so packets can be encapsulated back. Next. This is what we added in the -03 spec, where what if we need a branch point in between and we have to support these N3 and N6 interfaces in 3GPP. In Lisp, you can have an EID, and rather than having a single RLOC, you can have an explicit locator path. And an explicit locator path is a list of RLOCs, which means that the first RLOC is G-Node B, and since he's in this list, he knows that he has to encapsulate next to this midpoint. And then when he does a lookup, he knows he's in the midpoint, he needs to encapsulate there. And we can use this for service chaining or doing redirection for whatever reason you want. And then this guy just decapsulates and sends it in. Oh, here's my co-author, so he can interrupt.
I just want to add here, very important point here. On N3 and N9, what Lisp gives you is your underlay can be anything. It doesn't mandate that it has to be IPv6. You can use MPLS if you want. If you have existing network is MPLS, you can do TE on G-Node B to BPUPF or BPUPF to UPF. TE can be done on these two interfaces. Lisp is agnostic to that.
Okay, thank you.
Thank you, Uma. Next slide.
Yeah,
So,
one more, yeah.
How am I doing on time? Okay.
1 more minute. Yeah.
Okay. 1 more minute?
Yeah.
Okay. Okay, so handoff performance, like I said earlier, we have a signaling approach using Lisp pub sub. where whenever the RLOC set changes, the map server knows to notify the ITRs or the map caches that care about it. They send subscription requests at the same time they send map requests to the mapping system. That's the signal way of doing it. Arguably that can work, but it is slower because you're trying to get the information when you need it. If you use predictive RLOCs, the information is not needed. You always are sending packets to the decapsulators. So predictive RLOCs uses the bandwidth of the network and sends packets to where you think you're going to go. So if you have some directionality of movement, you can actually predict where you're going to encapsulate. So the remote guys encapsulate to multiple places. Next. So what we like to do here is, you mentioned that the IETF will select protocols and offer them the GPPP, and GPPP will decide. I think that's a good idea, but I want to go a step further. What we want to suggest in this proposal is that the IETF and the 3GPP work together to solidify the standards. We not only need network designers, but we need network operators, two from each group of those schools of discipline to work together, and it comes out as a combined standard, not this us versus they thing. We have to stop that sort of thing. We have to do the right thing.
Yes, Rashmit here. Yes, I totally agree. The aim should be to actually, as a part of the draft that we put together, we open the channel between ourselves and 3GPP and work together toward a common goal to actually see what changes we can actually make to the system.
Okay, thank you.
Can I finish the slides and then take time?
Yeah.
Okay.
Yeah, all right, yeah, good.
Okay, somebody asked to just update on the Lisp standards. So we've had RFC standards since experimental RFC since 2013. We're making a selection of some of the documents, are turning them into BIS documents and making them standards track. And these are almost close to working group last call. Luigi and Joel are here. I don't know if they're giving thumbs up, so that's good. Next. I'm almost done. And then these are all the experimental RFCs, and the ones that are grayed out, well, these ones are the ones that we're working on, and we're considering which are the other RFCs that we're supposed to make standard. Next. And then I'd like to just thank these people, and I do want to emphasize this over and over again, that we have to work together as a team here and not two independent standards bodies. Question?
Okay, yeah, very quick question. Yeah.
Tom Herbert. So I'm a little confused on what you're proposing for the data plane, because you mentioned that either GTP or Lisp would work, but the way I read it, I didn't see that either of those had anything in particular. It seemed like IP and IP would work. So can you comment on it? So is Lisp data plane part of this because it has something that the others don't have?
Yeah, great question. So I'll answer in reverse order. We don't want to do IP and IP because we need the UDP entropy, because there's router vendors that do lags and they hash on the UDP header. So it can't be IP and IP. This is something we learned from GRE, and when we built Lisp in 2007, all the ISPs told us do UDP, plus we needed to get through NATs. Okay, so that answers the first question. Then his next question was GDP versus Lisp. We can use either one. It's just an encapsulation. GDP can be just as dynamic, and it can perform the Lisp XTR function by doing lookups to the mapping system, but the data plane could actually use GTP-U. The main difference is that we have two features in the Lisp data plane that could be useful. One is Lisp crypto, because we have to carry key IDs so the decapsulator knows how to decrypt and which key to use. And we have this thing called echo nonxing, where we may want to test the reachability of the forward data plane in the data path, so an OAM type function. If the 3GPP people or the operators believe we don't need that, then any encapsulation could be used. Even ILA could be used. So, go ahead.
Yeah, we'll cut off the mic after Yari. Yeah. Sorry, we are a bit long. Yeah.
Suresh Krishnan. So, generally speaking, I agree with your sentiment, but there's no way it's going to happen. Okay, like we're not going to have, mainly because there's IPR considerations, like 3GPP works differently, IETF works differently, 3GPP is membership based. I cannot go to a 3GPP meeting personally. My company is not a member. So that kind of different contribution model. So that's not going to happen. So first thing, not going to happen.
You mean we're not going to be able to work together? Is that what you mean?
No, we cannot do one spec together, because somebody suggested either you or I because Dino started with that and he said you agreed. So that's why.
Well, Suresh, there's no reason why you can't copy and paste this text into 3GPP and have people work on it, right? I mean,
Right.
it's a mechanical problem and a human problem, but we're gonna try to
Right,
get
but
past
like,
that.
so the way it's done is like, this draft as written today cannot fit a 3GPP spec. Because like, if you look at a stage 3 spec, it's got way more details than what's in here, okay? So,
What's in this specification?
more than this, right? Like, because there's actually specifying bits in the wire, what are the options have been picked and stuff like that. So let's not go there. Like, I think it's like good that you have this, but I would like somebody from 3GPP to pick this up and run with it in 3GPP. And then like come back to us and we can have this collaboration all we want, right? But somebody, it's like, we cannot sit in this room and make 3GPP do some stuff. That's something I'm not comfortable with,
Have you
okay?
read this spec?
I read this document,
You
yes.
read this document?
Yeah,
There are bits on the wire described in that.
I understand.
Okay.
But the work has to be done in 3GPP.
Got it.
Like
No
for the
problem.
3GPP.
Yes.
Just making sure.
And these authors are willing to help 3GPP. Okay.
Excellent, thank you.
All right, Yari? Yeah.
Yeah. So this, I think, is interesting work. Thank you for that. I just came to say something about the sort of cooperation among multiple SDOs and wow, that, 3GPP, IETF, ITSI, and IT at the same time. That sounds a lot of fun. Maybe just two of those might be enough. But I actually had a serious point, which is that there's a good way of doing this, and then there's maybe the wrong way of doing this. And I'll start from the wrong end. I don't think we can write like one spec, and that these organizations also have different roles. Like the IETF typically delivers, great protocol components. You define Lisp, and then it's so good that it sells itself and it gets used in multiple different places. And I think that that's a model that we want to retain here, also from like a 3GPP perspective. They're more of a systems organization than a protocol detail specification organization. So they probably want to retain their ability to specify that, we're going to do, the overall architecture is like this, and not hand it over to a working group at the IETF. I'm guessing, but but the right way of going about these types of collaborations that you have overlapping participation, which I think we actually do have, and then people push ideas in organization 1 and organization 2, and keep things coordinating. And there's several of these types of efforts going on. Some work that we're doing in the even working group on authentication schemes is like that we try to go back and forth and refer to each other's work.
Thank you.
Thank you, Yari. Sorry, Dave, I think we had to cut off the mic actually. Sorry about that. Yeah, that's it. All right. So next, Satoru-san, SRv6 for mobile user plane. Can you use that, please? Sorry? No, US. Yeah.
Hello again, Satoru Matsushima, IETF Hackathon. Let's start. SRv6 for mobile user plane update.
Okay.
So we have received a bunch of the comment after the IETF 100 in Singapore. So we have many positive comment from on list and off list. So as a result, we adopted the document as a working group document. So, but that have some complaint about the mainly on readability. So we need to improve that text, especially on packet flow description. So the other thing is the concern on SRH. So SRH insertion or IP risk caps with SRH will be one of them, and also that's increasing head the seat will be impacted to the overhead size. And next is applicability for 5G architecture. Many people ask whether the 5G is the target or not, and also the other
generation architecture is targeted or not. So we need to make clear for that. And the feedback is how to cover the existing user frame protocol functionality, such like a GTPU message, which bring the end marker to make sure the handover performance much better, and also some of the extension header defined in GTPU need to be carried by the alternative protocol. So we need to deal with that. And also at the previous version, we just only mentioned about the IPv6 PDU, but the currently IPv4 still widely deployed, so we need to deal with that as well. So that's the comment from the community. So this is a summary list of the update from version 0 to version 1. So we changed the reference architecture from the almost previous generation to the 5G architecture. But it's not limited to do that. So we can refer any kind of the architecture if we need to mention, if we need to cover the function with the XRv6. So we change the terminology from the basic mode to traditional mode. It's much clearer for the purpose of the deployment scenario. And also we change the terminology, the aggregate mode to enhanced mode, which much enrich the functionality for the mobility management on the user plane. So next thing is use IPv6 encapsulation by default. Maybe it's the SRH. So it's thereby supporting other type of PDU much easily, IPv4, Ethernet, or any kind of things. And I think the readability of the draft is dramatically improved, I believe. So we added very precise packet flow diagram and pre-take alert, and I think it would be much better to understand how SRv6 works for mobile user plane. And also we cover the interworking scenario with the existing user plane, GTP. So previous version, we just support the IPv4 case of the GTP, and we add the support of the IPv6 GTP case. So next step is to deal with the feedback from the community. We will extend the function coverage that make sure the capability to carry the GTPU message and the extension header as it is, or some sort of the translation much suitable for the SRv6 manner. And we will integrate other type of the UPF function, UPF, such as the traffic measurement, interception, and multi-homing, and charging, etc. So that will be our next step. So then we will update the draft, and then when we reach a certain level of the quality, we'll ask the working group plus score. I mean, I'm not sure when it will be happen, but it must be close. So rest of the part of the slide will be reference. As much as friendly for this 3GPP format. That protocol stack picture make clear whether which is the SRv6 portion in the user plane side. We also cover the case which doesn't change the G node B, E node B implementation and N3 interface as it is. So we have a very good accurate slide for each of the deployment scenario mode. This is traditional mode. I have to save the time, and let's just go through the what we have in the slide deck. So we have a packet flow in uplink, and also downlink as well. And we introduced a new end function of the SRv6 to support the traditional mode. And the map is quite simple operation. Please read the document. So enhanced mode, different diagram here, and some interesting points listed on this slide. The packet flow uplink here and downlink. And also we mentioned that the IPv6 GTP case. So 3GPP style protocol stack here. So GTPU on top of the IPv6 on the N3 interface. So reference diagram here. And some objective is listed to deal with. And so uplink diagram here. Packet flow is be a little bit complicated, but I think you can find the how this interworking scenario works. And also we introduce the new end function, Nm GTP6 decapsulation in direction of the uplink. And downlink traffic diagram here. Packet flow, you can see that. And the N3 interface keeps as it is right now. We introduce the new end function on the downlink side. It's named Nm GTP6 encapsulation from direction onto the SRv6 to GTP direction. So this is the almost same with the previous version that cover the IPv4 GTP case. So 3GPP style protocol stack picture here. Reference topology is like this, as much as same with the GTP v6 case. Some of them objective is listed. Uplink, packet flow, you can see downlink as well. We introduce the function of the Nm GTP4E as much as same as the previous version, and also tmap in the direction of the encapsulate GTP2 SRv6 case. So that's what we prepare for this presentation. Thank you.
Thank you, Satoru-san. I have one question actually. Looks like in the recent version, you included a remove the non-encapsulation insertion of SRH header without IPv6 header. So any possibility of operating in the plain mode, in other words, essentially without tunnel requirement, in other words, insertion of SRH without the tunnel requirement. Any possibility you'll be able to get find some consensus on that?
Insertion mode?
Insertion of SRH without IPv6, without requiring an IPv6 header.
Yeah. If in the case of the IPv6 PDU case, it will be possible to deploy, but it depends on the standardization and implementation. And but at least the implementation side, we already have insertion mode in the working code.
Okay.
Suresh Krishnan speaking as AD for both this and 6-man. The segment routing header SRv6 specified today does not allow insertion in 6-man. And pending, I think like Darren is behind me, so he'll probably speak about this as well. So there is another draft which explains how to do this safely. So unless like how to do this safely is written, it won't be there.
Okay. But is it not just now ECMP v6 error handling? Is that the why? Is it possible to allow some essentially for certain use cases? We allow such mode, right? In certain content.
That's okay. So the safe header insertion draft is supposed to specify the cases where this is safe. So the idea was if you're in a closed domain and you can specify the applicability and the idea is to make sure that a host that doesn't know anything about this insertion is not going to get an ICMP error it cannot parse or understand or do anything about. Okay, so as long as that condition is specified by this other draft, which has not been updated in a while and explained, then we can consider it. But at this point, the SRv6 draft does not have this option, and it will not until the safe header expression is explained properly.
Sure. Thank you. Okay, very quick, yeah.
In the 5G, we have introduced the effective case. If effective case is activated, in such a case, QFI should be included in the GTP header. But for your paper, you do not check your paper, but in your PPT, you do not talking about the QFI. Also, in this one comment, the second comment is in the 5G, there's a there's also maybe SMF and UPF. There's a GTPU because there's a two type of when you in the idle mode. There's two type of nodes to buffer the downlink data. One is UPF, another is SMF. If the downlink data is buffered in SMF, then the SMF should data forwarding the data. Buffer data to UE when the UE enter connecting mode. In such case, there's also a GTPU is used. So in such case, I don't know whether also SRv6 is also used between the SMF and the UPF.
Okay, I think let's take this on mailing list. Yeah, Tom, please.
Tom Herbert. So I'm going to ask the converse question that I asked Dino. So this is using IP and IP as the default, but until it's resolved, that would have to be the way it is. Why not use a UDP-based encapsulation, and then you could unify with the Lisp proposal? Have you thought about that?
Dan Dukes from Cisco Systems. Just if I can, I just wanted to mention the encapsulation thing, and since it's come up a couple times. So I believe, and correct me if I'm wrong here, Satoru, but you have an IP and IP encapsulation. The IP encapsulation is IPv6 encapsulation, which also contains a flow label, which allows for load balancing to be done on that flow label. So in this case, IP and IP encapsulation that Dino had mentioned, we don't have that original problem. Okay.
Yeah, this is the opportunity to reduce the UDP data.
Right.
Yeah,
it's a good point. Yeah, thank you. John?
I've read your draft, and I think I posed a couple of questions. It would be interesting to see how this would work when you have multiple UPFs on the path of a single flow, how the segments would be handled.
Yeah.
That and the roaming case. And I also want to refer to that QCI part, the QFI, how that would be transported. So these are all challenges, and I'm going to...
Yeah, understand. Yeah, thank you very much. Your comment on the mail list. So I will deal with that. We have some idea to utilizing multi-homing with multi-UPF case, and also the QFI as well.
Okay.
So I really appreciate your cooperation.
Yeah. Final comment. Yeah, please.
Yeah, I think I just want to point out that with this approach, you have a unified approach or integrated approach for doing TILFA in the core, and then also doing service chaining and traffic engineering. So I personally like this approach because one layer does all the job. On the other ones, you have one layer doing every different function.
Right.
So I just want to highlight that.
Okay, thank you. Thanks for that clarification. Thank you, Satoru-san. And the next presentation is Arishmit's SRv6 as data plane for 3GPP N9 interface. We have 5 minutes. Please, you may have to stand in the box, yeah.
So I'm here to briefly talk about SRv6 as 3GPP in 3GPP network. So 5G networking right now is having some challenging objectives: simplification, UPF movement, delay minimization, support for 5G slicing. One of the most important one is smooth transition, smooth migration path, and last but not least is advanced mobility and fixed mobile convergence. So these are the challenging objectives that 5G is trying to address in their new study item that has been put forward. Next, please. So how SRv6 fits into this? SRv6 basically just provides is another one of the contender in the protocols that we have been studying for this task. So the current state of the business is basically you have GTP in UPF's connectivity, and then the first thing that we can do is to leave the N4 as untouched as possible and drop SRv6 as a drop-in replacement for GTP. Carry the GTP information within the SRv6 either as TEID or options or TLVs or such on 4, and then this basically allows to make sure that the other interfaces, the control planes in 3GPP are remaining intact, and from UPF perspective, you're just doing UPF control plane, the GTP control plane, and then SRv6 is dropped right in the middle. So once we have done that, we can actually start looking into some of the more modern options like TE and service chaining and entropy that comes naturally with SRv6. So these are, again, in some cases, we have to actually make changes. The question is that how are we going to obtain these SIDs? There are different values and different options that we have in terms of obtaining those things. SMF can be involved or it cannot be involved, or third party can be involved. So there are also different options that we can actually use to obtain the SIDs for traffic engineering, entropy, and service chain. Slicing, I've covered basically slicing in a very short form. If you have two slices, they can actually share resources in the network, or they can actually have completely disjoint path. SRv6 lends itself to this diagram in this design very easily. Slice 1 and slice 2, in this case, they are at the beginning they're using different set of disjoint path, and then but if the slice 2 requires to have a backup or protection path, they can actually start using the resources from the slice 1. Lawful interception and other features that come with 3GPP are important, and I took the example of lawful intercept in this case. The SIDs can represent a simple fork and forward mechanism and anywhere along the path, in any of the UPFs along the path, to actually support this type of lawful interception. So now what we have done this, when we have done this, we can now start looking toward more sophisticated designs and start looking toward advanced mobility with SRv6. Before I go, do you have a question?
I was going to hold off till the end, but
Sure.
if you want to take it now, I'll offer it now. Yeah, using a SID to say this is subject to legal intercept is an idea that is really bad and would not play. You're advertising to the whole network for any man in the middle attack that that particular flow is under surveillance.
But the SID is just a number. You don't know what it's for. It's basically is connected, is bound to a local function. What is it used for is basically the locality that knows about it. It will identify any functions in that node.
Okay, I'll be curious to see the details and whether that would fly past the experts.
Again, we haven't hashed out a lot of these things, but again, the important thing is the SID basically identifies a function within the node, and that function can be as hidden or as obvious as we want.
Yeah, it's just unfortunately as an example, you used perhaps the most dangerous thing you possibly could have.
Yeah, we can discuss this in a waiting list.
So now all these that I told you about, it can be achieved with SRv6 without making too many changes into the control plane. Now we want to actually go toward advanced mobility and with SRv6. These are like things like fixed mobile convergence. What we can do here now, we can actually start looking into the mode of operation where we use some sort of ID lock architecture in conjunction with SRv6 to provide advanced mobility and fixed mobile convergence. So what we do, the first option basically uses the UPFs as the IDs, but the IDs have no clue that they are running SRv6. They use GTP for the connectivity. The GTP gets intercepted by the locators, and the locators are basically the ones that are running SRv6 with. They use the ID lock mapping system. That mapping system can be anything. It can be a separate control plane. It could be a common database that is available in the network. There's a wide variety of different ways of doing this. The performance of this ID lock mapping system becomes an important aspect of how things are going to be done here.
Yeah, one quick comment on the mapping system. This connects to what Dino was showing, right, in the role of the mapping system in the 3GPP architecture. And also, I think what Charles was saying, how do we decouple the user plane from the data plane? And I think what is important is that Dino has presented the use of the list control plane together with either the list data plane or the GTP data plane. That's general, right? So you can use any data plane with the list control plane. So I think one of the things that is emerging, we have done a proposal of using list with ILA, but there is no reason why list couldn't be used with the list control plane, couldn't be used with the DSRv6
Absolutely,
data plane.
absolutely. Yeah, so that's why I purposely actually called it ID lock mapping system up there, because these two are orthogonal to each other.
Yeah,
the
exactly.
importance is that ID lock mapping system has to perform.
Exactly.
Right, and we have done some performance analysis, even using like common databases like DHT, and we are getting a sub 100 milliseconds performance time. But they can be improved, but nothing stops us to use the control plane like what Dino actually presented
Right.
there.
And basically what the list working group has been doing in the last, few months, years, is splitting data plane for control plane. So while we transform a Lisp into a standard track, there will be two RFCs, one for the control plane and one for the data plane that is Lisp. And then we can add other data planes. And that,
Thank you for here. We need to actually wrap it up. Please, please. No, we are running out of time. Sorry. Yeah. Okay, maybe just one comment. Yeah. Okay.
Actually, Fabio's comment made me want to make this comment. I think that from some of the presentations, before from Dino, and I'm sure other people behind, is that basically none of us are changing the GTP-C. Everybody's changing the GTP-U. So basically, I find the O diagrams important, but I want to underline that every single solution that we're going to present is actually, you can use the same diagram with a different name.
Okay, thank you. All right, concluding remarks.
Right, so as the final remarks, what am I here for? Well, I want basically the working group to start picking up what Kalyani, me, myself, and Dino and others, we are working on a draft, and we are trying to position that as a draft that compares different architecture, different protocols for 3GPP, and we can try. We are trying to actually get momentum here to position this as a partial response back to 3GPP. And would like to chair basically consider that in their response back to.
Thank you, Arishmit. Sorry we had to rush it up. Folks, please, post your comments. I think if there are many comments on this, please post your comments to the mailer. Kalyani's next presentation is Kalyani's on study on optimized mobile user plane solutions for 5G. Yeah, please.
So this one started as a response to the CT4 study item that Satoru-san mentioned before. However, in the last few weeks, SA2 also has approved a study item which is called Enhanced Services-Based Architecture. And one of the objectives in there is to see how the UPF can be connected to the services-based architecture. So I think at the end of this, we'll see if we need to include that in that, because IETF is working on the protocols and looking at the impacts on the architecture. If there are impacts beyond the N9 interface that we would like 3GPP to consider, I think we should consider them while we are working on this paper. There is this draft that we started, several authors. There are some listed in here and some have helped us beyond what are listed in here. This is the...
Okay, I can... Yeah.
Okay. Acknowledgements are there for a lot of people. We had a few calls on the DMM working group. Some participants came in from the 3GPP side and they helped us look at the architecture and gave us some input into what would be useful to have in such a paper that we can use as guidelines. And there were references, 2 references from the CT4 LS. And then there were 2 references that are from the SA2 architecture. And we have come to know that HC is also working on an NGP next generation protocol, looking at the same kind of work and trying to do the same kind of evaluation. It looks like there may be benefit of that they could also benefit from this evaluation being conducted right now. There are several protocol candidates in IETF. We started with a few of them like SRv6, Lisp, ILA. However, as we have been progressing on the work, we find that the control plane protocols and the user plane protocols can be mixed and matched, and some of that is coming up right now. And as you've seen in the Lisp talk and as well as in the SRv6. And there is this document, we call it a document. Maybe we should see how to move this. I think this came up on the email list. Should this be an individual document, or should this be considered as a working group document? And the scope of the work can then be guided such that it is beneficial to the IETF, 3GPP, and the HC communities. Little background on the architecture. I got a little feedback from the IETF side of folks saying that they hear all these terminologies and are not clear exactly how they all fit into the architecture. We may not have a full-blown tutorial right now, but maybe we'll scope it out a little bit later in another session. So what is shown here is from the 3GPP SA2 specification 23.501. They have two kinds of representation for the architecture. There are network functions specified and there are interfaces specified. The left side of the diagram shows what is called a reference point representation. And this one is similar to what you are all familiar in the 4G architecture. In 4G, you're familiar with the MME, S gateway, P gateway, PCRF, and HSS. In the 5G architecture, there has been a slightly different split of the functionalities. AMF loosely is called Access and Mobility Management Function, but it has some functions of the MME. SMF is the Services Management Function, Session Management Function. However, in 5G, the NAS is terminated on SMF and not on the MME like in the 4G. And then PCRF is now called Policy Control Function. Charging has something different. The authentication, AUSF is Authentication Server Function, and UDM. In the 4G architecture, there was a AAA and HSS function that, a AAA function that was included in the HSS part. There is similar functionality here. There is a new function called NSSF. It's the Network Slice Selection Function. And this is one of the features in 5G. The UPF, what they did in the 4G architecture, the S gateway, P gateway has been combined, and then they split it into the control plane, user plane part. So the SMF is the control plane part, UPF is the user plane part. So that is kind of what you see. There are a lot of point-to-point interfaces, and the concern was that having interoperability testing and running and operating these networks is not going to be simple. So the services-based interfaces have been defined also in the same release. The right diagram shows that the functions are same. There are some additional functions. Each of the control plane functions has a services-based interfaces. And each function would say what services it offers to the rest of the functions. And they are registered in what is called an NRF, Network Service Repository function. There is also a data storage function. Actually, it is also applicable for the reference point function. If some of these functions are stateless and can share this storage function, they can do so. And then there is an NEF, which is a network exposure function. The services that are offered in here or the data collected in here can be used by the other parts of the network or for exposure to the external parties. So that is a quick rundown of what the architecture is. So what we will try to do in this work, in this document, is we are looking at the services-based interfaces. So the diagrams that you have seen in the Lisp and the SRv6 thing kind of fit into the architecture that is shown on the right side. There is an SMF, and you see the UPF, two UPFs with N9 between them. And that is kind of what you saw in the documents, in the presentations before. In the document, you see how the rest of the other protocols fit into the architecture. 3GPP also has roaming architectures, and the relevance for this is N9 sometimes goes across operator boundaries. these terminologies are very specific to 3GPP mobility and roaming, and some of the IETF folks wanted to know what the definitions are. We found that there is a 3GPP document 21.905 that has the definitions of those, and the requirements are given. We put up the specification names, and there are also specific section references to say where the roaming requirements are listed and the mobility requirements are listed. In the roaming itself, there are two scenarios. One is called the local breakout scenario, where when the UE is roaming in a visited network, the service could be offered by the visited network itself. However, the authentication is done with the home network, and the policy could sometimes come in from the home network. The home routed case is where the services are offered by the home network, and in the bottom diagram, you see N9 crossing the operator boundaries.
Okay, one second, Kalyani.
Yeah.
So where are the blue sheets, please? Did everyone sign the blue sheets? Where are the blue sheets, folks? Yeah, okay. If please, everyone, please make sure you sign it. Yeah, please continue, Kalyani.
There are several more configurations related to the N9. We have some samples in there. For example, this top diagram we show has multiple PDU. When a UE connects to two different data networks with two different PDU sessions. So in that diagram, you see the G node be connecting to a UPF and a data network with its own SMF for each of the two cases. The network design decides whether there is an N9 or not, but on the sample thing we show the second session connecting to two UPFs with an N9. The concurrent access is where you can have access to two data networks but with one PDU session, in which case you have one UPF as a branching point. I think one of the presentations mentioned this, and it could connect to two data networks there. So regarding the requirements for this study or this evaluation is the UPF requirements are specified in there. Basically, the mobile anchor point, UPF is the mobile anchor point, and it has all the packet processing, routing, all the functionality that you're familiar with in the 4G architecture remains. There are new QoS tables in the specification. They also have a reflective QoS this time, so the N9 has to map all of those as well. So those requirements are in those sections. And we have identified a few scenarios for evaluation. It would be good if we get input from the other operators as well. What we have picked is non-roaming scenarios where the UE connects to the internet. There are three mobility cases defined in the architecture. One is called a service and session continuity mode 1, which means that the IP address does not change. And service and session continuity mode 2, where the IP address can be dropped and then reconnected. Service and session continuity mode 3 means that it can drop and connect, however, there is no impact on the service. What this means is you're making the session before you're baking it. So that is why the service is having continuity. And the other scenarios are UE to UE, because everybody is talking about the low latency applications. So we need to ensure that the UE to UE packet flows happen, and then mobility also is supported. UE to two data networks with multiple PDU sessions and single PDU session, those are what we picked up. And then roaming scenarios, local breakout, and home routed. We need to see each of these proposals that are being brought in for the evaluation. How do they support all of these? Then the next set is related to the slices. Not all slices may be using the same mobility management mechanism. So the system has to support slices. Each slice could have a different mobility management mechanism, and we would like to see how the protocols behave in such scenarios. And we have one requirement that says if a UE is connected to multiple slices using different mobility protocols, we're hoping that we'll be able to address that as well. Then we wanted to see what the impacts to N2, N3, N4, N6 are. The N9 has, around the N9, there are these other interfaces. we would like to see what the impact of those other interfaces are. And then, is there any impact to the functions surrounding the UPF, G node B, AMF, and SMF? So we wanted to look at those as well. Okay. Go ahead.
For my understanding, whether use TTP or other protocol like SVRX V6 or PMIP in the 4D is per PDU session, is not per slicing in my slide.
I'm sorry, I missed the second part of your comment.
I think that the TTP protocol or PMIP or SRv6 is per PDN connection. It should not be per slicing, my understanding.
Okay, maybe we can refine the requirements. We started these as high level. So once we get some more input, if there is input, please identify so we can get consensus that these are the right requirements we are looking at. And so you have seen these protocol stacks in the individual presentations before. Just to put them in the context, the top left tile shows the existing 5G protocol stack. So the N3 interface and N9 interface, N3 interface is between the G node B and the UPF. And there is a GTP over UDP over IP over there. And then there is an N9 interface between the UPF closer to the edge and the UPF that is closer to the internet or the data network. That is the PDU session anchor. It's called 5G user plane encapsulation in here because the work is still progressing in 3GPP and they need to see what are the extensions necessary for the GTP header.
Okay, time check 1 minute, Kalyani.
Yeah, and then the other three protocols are showing that. I think you have seen all of these. Let's go to the next steps. What we would like to do is expand on the description of the protocols in the document for roaming, charging, security, and scalability and other stuff. What we would like to ask is, can the DMM adopt this draft as a working document? And then when we respond back to 3GPP, we can send a copy of this. And we were included SA2 in here, even though we did not get an LS from SA2. And the thing is, we would like to propose a joint 3GPP IETF meeting sometime in July, if that would help the two SDOs to understand what is being proposed.
Okay, thank you, Kalyani. I think a lot of work went in only in the last 1 month, so we would need few more discussions, and based on that, we'll talk to the AD and try to decide one way or the other. Yeah, quick comment.
Just one comment. Thank you very much for your such extensive work. I really appreciate the standpoint of the CT4, and I really appreciate it. And as I mentioned before, that's the work is really huge. So, but I really appreciate if you can make the document much easy to digest. So that would be a very concise comparison criteria or some other dependency on the architecture, on the generation, which Suresh mentioned before. Like so, this is the user plane only solution. Technology, and also other kind of the that require architecture change, such you mentioned on the SVA study item in SS2 maybe. So that's kind of the clarification or the and also the document of structure is really helpful for the CT4, I think. Thank you very much.
Okay, really sorry, but we need to cut off the mic there. We are way behind. Sorry. Yeah. Please post your comments in the mailer.
Very quick. I'm sorry. I just want to speak strongly against the working group adopting this or using this as the response to the request from 3GPP. The request was for a list of things that are relevant. I think that is something we can produce. A full comparison and evaluation would be a very bad idea.
At this point, we haven't issued an adoption call yet. So it's a, you can absolutely, provide that feedback during the adoption call. Yeah. Thank you. So, this is the draft that, I posted actually. I think, unfortunately, Depeng is not, my co-chair is not there, but this is an individual. So So this is essentially, if you look at, I think what Kalyani and Satoru-san has presented overall with respect to, 5G user plane optimizations. I think the key goals are, how do we realize an access independent, user plane? That is one aspect. Second thing is, how do we truly, leverage the data plane, have some optimal routing in the user plane? If you look at the classic mobility architectures, it was always an anchor-based approach where we would, steer the traffic from that anchor point. So with respect to routing, there were like many inefficiencies, and I think, it's time to really remove that, inefficiencies in the data plane, right? That is one aspect. And also, given that, the next set of, billions of IoT devices, if you have to scale the network to few billion IoT devices, question is what kind of, what kind of optimizations do we need in the user plane? I think that is another aspect. And the one thing is removal of the anchor. I think, today we drive everything through centralized mobility anchors, whether you take a GGSN, Horizon, P gateway, or any of that. Fundamentally, we always had an anchor, right? The question is, how do we remove the anchor? So if you look at the study item that Kalyani talked about, it was mostly about N9. But when you talk about N9, there's an anchor, right? The anchor is not going away. So you're only between 2 points on the N9 between 2 UPFs, you're removing the tunnel, but fundamentally the anchor is there. I think so. This specification is, this work is about like how do we remove the anchor from the user plane. I think that is the goal is also to remove the anchor. And now with respect to whatever we do, we have to coexist with the CUPS architecture. Because 3GPP, most of the mobile architectures are already heading in that direction with respect to user and control plane separation. So that is another thing. Now, so if you look at it, symbolically, like as a picture, really, right? Your user plane is separated. In the user plane, you don't want any protocols, right? Essentially, the control plane is already separated out. I think so whatever solution that we pick, right? At the end, we don't want to introduce a control plane again in the user plane, right? Because the goal is to we have already separated the control plane out from the user plane, right? So now what we do on the user plane is whatever, if you can leverage the routing semantics and steer traffic, I think that will be the goal. So in general, I think this is like elimination of centralized anchors, optimal routing, no tunnel overhead. Obviously you want to scale, but that's subjective. And state reduction. I think the state that you introduce in the user plane, to as far as possible, it has to be minimal, right? And finally, you have to leverage the QoS that is present in the transport, and you have to steer the traffic with some traffic awareness. So the approach that what we are proposing, right? I think how do we realize that with SRv6 or any other user plane which can steer the traffic in optimal plane. I think this is more about how we this is an approach where you don't where we can get rid of the anchors. I think that is, let's look at quickly a call flow, right? In this approach, when the mobile node comes up, initially it is anchored at the local access gateway. It's almost like a first hop router, right? This is your starting point, right? So the IP address that is given to the mobile or the UE essentially is from the address prefix that is anchored on that access gateway. Now at this point, if you see the traffic flows, the flows are optimized, right? Essentially there are no tunnels, there's no user plane state in the network, right? Essentially because your all traffic is entering from after the base station, your first hop router, everything enters and exits from that, right? So in that sense, traffic is optimal. The user has multiple prefixes with colored prefixes, one prefix with address properties, another prefix without address properties. But the question is, now if the mobile moves, right, what do we do with this? The mobile which was on AG2, right, now it moves to AG6. Now there were active flows at this point. Now what would happen to those active flows at this point? This is where I think what we are saying is essentially initially when the mobile moves, that event would be we would get that in the control plane, somewhere in the there's a mobility controller will get an update either from the SMF, AMF, or from in the radio network, right? Based on that event, we know that the mobile is now somewhere in the base station, attached to AG6. Now, in one approach, at this point, the default policy that can be pushed to AG2 and AG6, which says that any traffic for those previously assigned prefixes can be directly routed between AG2 and AG6. That is one aspect. Second thing, also with using the semantics of SRv6, we can say that any time you see an optimal flows, right, report those flows to the mobility control plane. So this is more about steering, but in this case, essentially still there's an anchor. If for a transient period of time, the traffic will still go through, essentially like this from AG2 to AG6. But we don't want this because this is like the pinhole routing that we have had this problem all along, right? Now, can we leverage SRv6 or some other approaches where we can get rid of the initial anchor from the path? So this is where I think the default policy, the very initial policy after the radio event is we are saying any traffic that you see from AG2 to steer it to AG6, right? The second thing is any optimal flows, if you see, report that to the control plane. So now the initial flows which are there at this point, if CN2 is talking, obviously a packet would end up at AG2. At this point, the AG2 will report that flow metadata to the control plane, and the control plane can pretty much, say that, identify the best routing path for that. In other words, the CN anchors, what we have is the concept of a CN anchor, and say that, for internet bound traffic, probably one of the exit router, R3 is maybe the best router for that, CN anchor for that outbound, for the internet traffic, and maybe AG4 for some other correspondent node which is inside the network. If we can push an SRv6 or some other user plane policy which says that, traffic, send it directly from, R3 to AG6 or, AG4 to AG6, at this point, for those flows, there are no active, essentially, the AG2 is no longer in the path. So finally, at this point, once, those flows terminate, at some point, those flows will terminate, we renumber the prefix, and we now give a prefix from the localized anchor. At that point, again, the network has converged back. So we started with no state. And for a transient period of time when there was mobility event, we created there was some SRv6 state or some steering state. And later we removed that state, right? Now again, the traffic, essentially we removed the state with no tunnels in the user plane. Essentially, we are back to the square one without any special steering state, a tunnel state, or an anchor in the control plane. So that is summary. I think that this is about elimination of fixed anchors, elimination of user plane tunnels, right? Traffic steering with cost awareness, because we can use some semantics in the innovation, the SRv6 or whatever, right? Essentially, we can steer the traffic, and what we have is an access agnostic plane, right? So this is the proposal we published in document, and please, Charlie.
So thanks for the presentation. You went pretty fast. I have to go back and look at the details, but so I'm Charlie Perkins from Huawei. So you're treating anchor as a bad word, and really, if you think about a mobile device has an address, let's say it already has an address and it moves, there's got to be the packets from the internet have to go somewhere. So wherever that is, and in that diagram, you've got interesting things called Topology DB and Location DB, and those things are usually owned by something you would call an anchor. And so you're doing updates to anchor data and so on. So, and I agree that it's nice to distribute the signaling so that you can have localized anchors when you don't need to go across the large paths of the internet. But that also increases your signaling. If you're going to have to do you're going to have more signaling devices that know how to handle new protocol. And so it's a trade-off. And so I guess my point is not so much of a question, but I just would hate to see the word anchor devolve into being a curse word. And it really needs to be considered as an essential part of the architecture.
Right. I think you made a good point with respect to the signaling, right? It is true. In this case, potentially, there can be, anytime there's a mobility event, at that time there are active flows, there's a lookup that happens. But if you look at any of the mapping protocols, even there's a cache lookup or cache population. So it's the same thing is happening, but here we slightly do it differently. But it's a fair statement. But maybe based on policy, we can do that. Yeah, John.
Hi. John. So one thing I see in this figure is that the optimization of route is taking place between the origin and the destination. And I think as I see it, I'll relate it to what 3GPP is doing, at least, they map it on the half call side, so it's only on the origin side. So there is some optimization that's taking place, and we may want to look at that in terms of how that works.
That's a good point. I think the question is, 3GPP 3GPP, anything on the GA interface or on the N6 interface, they don't talk about it, right? Here, potential that R3 can be on the N6 interface, right? So some of these discussions need to happen exactly. How do we represent, some node where there's a, some interface to the SMF, AMF through that node, right? It's an SMF, right?
I think that's the point.
Yeah,
I mean,
absolutely.
you may have different domains,
I
where
agree
you
with
have-
that. No, I understand that. Absolutely, yeah.
So the another comment is, when I haven't read it in full detail, but just looking at it, it seems a little bit more like the SDN kind of control where you're distributing forwarding. So there is a limit to how much you can do that. In some sense, I mean, maybe it's like a distributed routing, but this is more like distributed
Yeah,
forwarding.
see, we can do this selectively, right? We don't have to do it for every flow, every user. Maybe, there's some mobiles which are, rapidly moving. We don't do this, right? Only for certain cases we do that. But at the end, what we realize is a system with practically, very minimal user plane state. I think this is.
No, I mean, it's a first revision, so I'm just giving my comment.
Right.
And one last comment is when you do the mapping between these nodes and what's on 3GPP, there's a lot of topology databases and so on, but there are equally topology databases like AMF and others. So there needs to be some alignment over there. But that's only for that use case.
So Suresh is managing the time here.
Yeah, I'll cut the
Otherwise-
mic line off now, so you can all make a statement, but yeah, please go ahead.
Okay, Dave Allen Erickson, just very, very quickly. And this applies actually to several things I've heard today. And that is the elimination of anchor points if you're purely considering forwarding is actually relatively straightforward. It's when you start getting into requiring virtualization, carrying session metadata, stateful handoff, and in particular, it's that state handoff in any type of mobility event that's actually kind of huge. And you end up at classes of applications that don't necessarily need all of these things, but some of that stuff needs to be there and is going to be inescapable. But we might as well understand that when we talk about many of these approaches, they are only applicable to certain use cases and not across the general business of mobile networking. And you need to consider the whole business of mobile networking. So that's a kind of a high level heads up.
I agree with that. Yeah.
Thanks, Dave. Yeah.
I can provide some background information on the 5G. Now in the 5G, we have introduced or defined two similar solutions. The goal is same. One is for the SSA Model 3. This means SSA Model 2 and SSA Model 3. This means when the UE change it to another place, we can change the anchor. Another solution is defined by the 5G is the mobile edge computing. That they say the edge computing means that they use the local area data network or application influence the user plan selection. I think you can consider or reckon some you can define in 5G.
Okay, thank you.
All
Thank
right.
you.
Thank you. Thank you, Suresh. Thank you, Suresh. Yeah. Next is Carlos going to present on PIM 11. So very quick update because we had to issue the adoption call as well. Yeah.
Okay, so very quick update on this draft. Overview is a network-based DMM approach based on proximal IP, in which mobility management is pushed to the edge, and is basically a partially distributed solution with a centralized control plane and a distributed data plane. So there are, in terms of entities, there are two types of entities. What is called the mobility anchor and access router, which is basically the access router where the mobile node attached to, and is the one concentrating the access router, LMA and MAC functionality per mobile node per prefix. And is the one delegating the prefixes that are then anchored to the different mobile nodes and sessions. And then we have the centralized mobility database, which is basically kind of an LMA for the control plane. So very, very quickly, the operation very simple. When you have initial attachment, you connect a mobile node connect to this MAR, and the MAR then signals that to the centralized LMA, which then gets the state, and it gets a prefix locally anchored here, so there is no tunneling here to get to the internet. If then that mobile node moves to another MAR, basically the same signaling will be sent to the CMD, and then the CMD will signal back to both the current MAR where the mobile node is attached and the previous MARs where the mobile node was attached, to allow the session continuity for the prefixes that are anchored at different MARs. In addition to, of course, provide a new prefix or a new prefix to the mobile node locally anchored here, so it can use for the new sessions the optimal path with no tunnel, and for the ongoing session it can keep the session continuity. So as I mentioned, there's running code for this. We even show in the IETF in different occasions, and we are actually keep on using this even for teaching purposes at the university. So it's running code for there is running code for this. So just very quickly going to the last slide. So there was version 00 that was the first one merging a couple of previous solutions draft that was presented in Singapore, and I think we got some good consensus for adopting the document back there. Then we have version 1 that has been posted before London. We addressed some comments that we received in Singapore from Danny and from Sri. We have had some discussion on the main list. We have received comments and reviews from Dirk, Simpen, Alex, Akbar, and Daniel, and I think I also received some comments from Satoru or previous to this meeting, and I also got some offline discussion with Danny Moses. So we believe that the document is ready for adoption. So, any questions?
Thank you, Carlos. Any questions for Carlos? Okay, how many people have read this document? Okay. 1, 2, 3, 4, 5, 6. Okay. Okay, this is Charlie 7. Okay. So, okay. So, yeah, go ahead, Charlie.
I'm Charlie Perkins from Huawei and FutureWay. So there's been a lot of work in this general space, and this is a nice version of it. But some of the previous work had important things like pre-registration and context transfer, and there was a document called Fast Mobile IP, which I think should be considered relevant to this. So I'm wondering, well, I mean, I guess one of the features of this is a creation of something called a logical interface, basically. And I wonder if you consider this to be an intermediate point along a general design or something. I mean, this has a lot of resemblance to what Sri was just saying in certain ways. And so I think what I'm trying to say is that it opens the door to a significant design space, and I'm wondering if you agree that there could be a lot of modifications in the future.
Yeah, I mean, this document started to be like a kind of direct, straightforward DMM solution from PMIP. But of course, we agree is the document, I mean, if the working group adopts the document and the working group believes that we should improve or add other functionalities and go in a different, I mean, evolved direction, yeah, of course, we will agree to do so. Yeah, to consider other things and to extend the solution with that. But I mean, the kind of the trigger for the document was like, okay, there is this DMM, there is PMIP. Let's try to do a PMIP-based solution.
Right.
That is DMM.
Well, I guess part of my motivation for asking the question is that we're, focusing a lot of attention on 5G, and 5G is nothing except, if it's not high performance. And so adopting a new approach for local mobility, I think should take a lot of effort to make sure it's high performance and fulfills some of that need.
Yeah, fully agree on that. Yeah.
Okay. So in the last IETF 100, we polled the working group and there was consensus, but at that time I was not ready because I did not see many discussions in the mailing list, right? But looks like lately there was some discussions. I saw a bunch of people commenting on it, right? And so I think just a rough poll, right? Anybody, how many people, support the adoption of this document as a working group document? One, two, three, four. Okay, five. Okay. Yes. Okay. All right. How many people oppose this work to be adopted as a working group document. Okay. Suresh, what do you say? Okay, all right. I think so. Roughly, there's consensus, but we'll discuss with the AD, and we will poll again. We'll confirm the same in the mailing list, and if there is sufficient interest, if there are no objections, we'll take this up as a working document. Okay, with that, thank you. Next is Wuchi's. I think the RA extensions for on-demand mobility. This is based on a 3GPP requirement. Wuchi, you may have to rush it up. My apologies, but. Where is the flipper? Carlos? Yeah. Yeah. Okay.
All right. Is this on? All right. As you know, router advertisement, RARS, is one of the ways for an IP node to configure its routing address. One of the things with distributed mobility management is that there may be a need to allow sort of options with a particular set of prefixes. As mentioned earlier by Sri, there's a LS statement from 3GPP regarding RA metadata related work. And in particular, they've defined 3 SSC modes, and it was mentioned in Kalyani's talk a little bit earlier. And what SA2 is looking for is a mechanism to deliver information regarding SSC. So the idea is that a UE coming online may have a set of options available to it, and this is the way for the network to specify what those are. This is based on, there's a on-demand mobility draft from it's Alper, I forget his last name, Yegin, and Danny and company. And in that draft, there's these 4 modes of operation: session lasting IP address, fixed IP address, graceful replacement, and non-persistent. The starred ones are the ones that are mentioned in the SSC. They map to SSC modes for 3GPP. All right, and so there's a nice mapping between what's going on in the on-demand draft and what's going on in 3GPP. We presented something at IETF 100, and we've...
Sorry,
Yes.
am I allowed to ask a question?
Yeah,
on the
please.
previous slide?
Go ahead, yeah.
Philip Erdley. So is this a negotiation, supposing the UE wants one sort of service continuity and the network's prepared to offer another sort, is there a negotiation, or how does that work? Or is that not a valid question?
Well, so in this particular option, the mobile network can actually specify, if it's got these 3 different options available to the UE, that it can put them all in the RA. Okay. Yeah, and the UE chooses.
So the prefixes are colored, Philip. Yeah. Okay. Yeah.
And so we got some feedback from Suresh, Sri, and others from previous IETFs, and the 2 most realistic possibilities at this point, we believe, are either modifying the prefix information option in RA slightly to convey the session continuity type, and this requires us to modify some of the bits which may or may not be popular. The other is to add the prefix option type here is set for 3 for the prefix information option. And so one other possibility would be to modify that or add another type so that we can specify this for mobility.
Comment on John. The comment is, 3GPP has got a control plane which is going to advertise SSE modes 1, 2, 3, and so on. And now,
where is that, John? On the IP plane, on the NAS signaling? In the NAS signal?
The NAS.
But you're not doing allocations in the NAS signaling, correct?
No, you're not.
Then how
but
can
it
you indicate
does-
the prefix color?
But it does advertise the SSC port. I mean, what SSC is.
On a PDU basis? How do you do that?
On a PDU basis.
Okay.
And now this control plane is going to advertise in RA what the address type is, right? I guess my comment was, are you going to look at what happens if the 3GPP control plane advertises one mode and the RA advertises another mode?
That could be entirely in scope, yes, if that ends up being an issue.
But if there are multiple prefix assignment support now, is it required that all the prefixes have to have the same mode? Is that per PDU? Is it on a flat PDU basis? On a prefix basis?
It's on a prefix. I mean, prefix basis.
Then he has to do that, right? See, the thing is, if we say that the entire PD is only dedicated for one particular, particular mode, I agree with that. You indicate at the NAS signaling and done, right? But if we go with the assumption that on a PDU there can be multiple prefixes, each with the different service modes, then he has to indicate
sorry,
it.
the PDU is a prefix. It's related to prefix. It's not multiple prefixes.
I think we'll take it off.
Yeah,
Okay.
we should look at that. That was why.
Sure. Okay. Yeah.
Lorenzo.
Well, Lorenzo Kalui, I think you'll have a very hard time getting bits from 6-man. You might want to look at the PVD work that's going on in the interior work group, which is looking at expressing this stuff in a sort of more extensible format. I don't know that it'll do exactly what you want, but
We've actually had some discussions with the PVD folks. The issue there is then you require an additional, you have to get the PVD and then you have to go off and.
But that might be cached, right? It might have, the sequence number might be the same, and so the UE might already have it. And maybe there's a way in the JSON to encode, this block of prefixes has these properties and this block has this other property, and then you basically match it. Right?
Yeah.
So because realistically, like 6man's in a position to block this forever if they don't like it, because it says that the charter says that it can, right? Says it can recommend that the document not be published if they don't like it. So
yes, we understand that there are many battle scars that have been had in trying to touch bits.
So I just want to comment regarding PVDs. We looked at that. There's also an alternative of using DHCP, and there are even other alternatives. I know you like DHCP. I had to come and say that. Anyway,
now you'll have full support.
as a response to the initial liaisons from SA2, SRI responded to that and indicated various alternatives, including the PVD stuff. And they came back and said that they felt that the RA option is the most promising one. Now, so this is at least what they prefer. I would like to understand what is why you don't like the RA alternative. It's so simple. Oh, so why are you suggesting something else?
Yeah. Danny, Suresh and I had a draft long back. We never managed to push it through. We started in DHCP, then there was some work happened in MIF working group, right? It went through all and finally, we never. But maybe timing sometimes, right? The coloring work is taking off. It's just with a different name, right? It's sometimes timing. Yeah.
So if you don't have any objection to modifying the RA, we would love to have support.
Right. I think we are good. The difference is at this time there's a 3GPP, LS asking for it, right? Which is a good thing, right? Maybe based on that, maybe who knows, we'll, talk with ADs and 6-man chairs, and let's see if there's consensus. Maybe we'll be able to find the bits, right? Yeah.
For what it's worth, I don't object to this at all. I mean, so let's just be clear about that. I think
it has many scars.
Yeah, no, I mean, I think so. First of all, if you haven't gone to 6-man with it, you should go. Right, ASAP, and I think if I feel that if it was cast as like a link layer specific option or something that wasn't universal, because I think those bits are basically used on every link type on every network, right? And so I think that's why. But if you manage to something not necessarily a vendor option, but maybe like a link type specific option, and there was a registry of options that were different per link type, maybe that would fly. I don't know, but it's
I think one of our thoughts was that if we had this as an adopted work item here, that would give us a little bit of legs to stand on over in 6-man, and it might ultimately we might get more scars coming back.
No. What I'm saying is, if you do this, then it will take you longer to get the answer that you don't like.
Yeah.
So I would no, but if you get the answer that you don't like, it will take longer. So I would. So to be clear, like if you want to try to adopt it here like today, then like you could still go whenever to 6-man, right? So I don't object it. I don't object to that.
Regarding Wuchi's question, he showed two alternatives. One is to use the existing type 3 option and use some result tricks.
Let's take it in the mail,
What would be your preference then, I guess? Or a new.
Yeah. Okay. I think this timing is right. I think let's try. Okay. So we'll take up in the mailing list. We'll discuss with AD. 6-man shares. We'll find a way forward for this. I think I'm not saying anything at this point, but we understand the requirement. This is important, right? We understand that. So we will find a way.
What is the next step? Should Wuchi post it already on the 6-man?
No, you have to socialize it.
Okay.
Yeah, you have to socialize it. If please ask for a slot in 6-man or whatever. If it's not too late, maybe it's already done, I guess. Right? Yeah. Next, exactly. Yeah. So next is final presentation from Seal John. Seal, my real apologies. So yeah, 5 minutes.
Yeah, actually that I was expecting that more times, but anyway, so thank you. And it will be some quick update and about the Dmm Deployment Model and architectural consideration. Actually, that update was given in the last meeting, and so based on the comment in the list. And so the new version, 04 version, will be submitted, and with the following update. But update will be very small, and the last model will be named, and some missing interfaces in the models will be just added. And actually, that we are still waiting for the comments and opinions based on the stabilized FPC draft. But here, what the stabilized means here is that as the FPC draft is still progressing based on the implementation, so we are just leaving the spaces subject to change. But looking at this, that FPC draft, and also looking at this our architectural consideration deployment, that what you have just done is about the pointing out that where FPC interfaces will be applied. So in terms of that, I think that there's nothing will be conflicted with this current FPC draft ongoing. So anyway, that if this FPC also gives some comment, that we will post the new update in the list. And then what we are very importantly identifying is that new work stream is being done and proposed for user plane of the mobile networks and with the tool following the title. And also we'll be welcome to get the comments of some relevant authors, and particularly to identify the impacts of those works on the existing deployment models, that what we'll need to consider additionally, but if not, that also will be welcome to get some new opinions directly in the list. Actually, also additional trend we are identifying is the 5G service-based architecture, and this appeared in the last year, that December, that this version appeared. So, and also today that we could see that some couple of the presentation talking about the SPA. So also we saw that this deployment models almost stabilized, we believe so, but we also saw that there needs to be considered based on this 5G SPA. But actually that the last model given in the draft, I think is well reflects this SPA concept and some in a big picture. So, and what we have just done is that just that adding some interfaces between the mobility controller and the control plane function pools, and also between these control plane functions and the routing controller. So nothing has been changed, that only except adding these interfaces. And but actually that what we are also asking is about that, what else or any additional, any opinion or comment to be considered? And if not that it is good enough or not, so maybe that, yeah, so in terms of that, we, solicit that your comment and opinions. Yeah, that's it. Yeah, Charlie.
Thank you, Seal. Charlie?
A quick question, I guess quick. I'm Charlie Perkins from Huawei. Just curious if it makes sense to show some of the 5G architecture and how this is embedded in that. I mean, with N9 and SMF.
Sorry, so what is your user questions? And
we've seen several discussions about the 5G architecture.
Yeah.
And I think this is relevant to that, and it should be some connection made between those two.
Yeah, but actually, when it comes to the 5G architecture, what do you mean that?
Well, what you showed in the picture fits somewhere in the 5G. For instance, you already cited that.
Yeah.
And so, go to the next slide.
Okay, we need to close the meeting, please.
But I think that this model is already, will reflect this 5G model, architecture model.
So in other words, if it's already like it, it should be an easy project to actually show how it's like it.
Okay.
All right. Thank you, Seal. I think, yeah. With that, we close the meeting. Thanks, everyone. Thank you. Please, if you haven't signed the sheets, please, yeah. Thank you so much. Yeah. You're happy with the time? Did I give
This working group keeps focusing on the data plane, we're going to make the same mistake as NBO3. We have to focus on ensuring
control plane is, the battle is lost, we cannot, no, yeah, they'll never occur. See, your Lisp control plane, you can put it as an overlay, right? In other words, your database, you can put in a 3GPP, but run a parallel interface, that's okay. But don't touch the rest of the control plane. Just as a service interface.
Locator ID control plane.
Nobody
Nobody talked about that.
I see.
Scaling security and mapping system. We all talked about moving packets, but that's not the most important. So the focus is this guy.
No, I agree. Yeah, no, fair point. I think
so. So maybe.
Yeah. Next time we'll take proper time and discuss this.
Locator, right? All the solutions that we
You sign, right? That's it. Thank you.